Okay, so dear students, welcome back. And today is our fourth video on the topic nonlinear first order partial differential equations, and we will be discussing the fourth type today. So, what is this fourth type, or simply type 4? Type 4 will be of the form z is equal to px plus qy plus some function of p and q. So if you are observing, you will see that this equation has z, it has x, it has y, it has p as well as q. So all the five it has. And this has this standard form, and this form is actually called as the Clairaut's form. Okay. So we will be discussing the Clairaut's form today, which is this form. Okay. Now, first thing is that how to find the complete solution. To find the complete solution, we will simply put P is equal to A and we will replace Q by B. So if you see what will happen, if we put P equal to A and Q equal to B, so this will become Z equal to AX plus BY and this function in terms of A and B. So this actually will be our complete solution. Okay. Why this is a complete solution? Because Z is equal to something and it contains only two arbitrary constants. Okay. So this is a complete solution. Now, sometimes what they will do, they will ask you to find the singular solution. Singular solution. Now, to find the singular solution, what you will do, you will use two relations. The first one is you will put dou z by dou A is equal to A. And you will do some simplification. And the other relation which we will use will be dou z by dou B is equal to 0. And again, we will do some simplification. Using these two equations, we will try to write A and B in terms of some function of x and y. Depending on the question, we will have the expressions depending on the question. Okay. So A will be represented as a function of x and y, and B will also be represented as a function of x and y depending on the question. And whatever expression we are getting for A and B, we will substitute in our complete solution. So that will give us the singular solution. Let us take an example and try to understand what we have discussed so far. Okay, so it becomes more clear. question. Question is find the singular solution of this partial differential equation, which is in the Clairaut's form, z equal to px plus qy plus some function of some function of p and q, which is in this question, let us take it as 3p square plus pq plus 4q square. Okay, so if they write in the question that find the singular solution of the Clairaut's equation, that is fine. If they don't write also, it is very easy to identify the Clairaut's equation, because you have seen that Clairaut's form is of this type. Z is equal to px plus qy plus some function of p and q. So if you see the given equation, it is same as z is equal to px plus qy and some function of p and q, right? So first we will find the complete solution. We have already discussed that to find the complete solution, we just put p equal to a and q equal to b. So therefore, the complete solution will be obtained as z is equal to ax plus by plus 3a square plus ab plus 4b square. And how we are getting this? Because we have simply substituted p equal to a and q equal to b. This we have done. Okay, so this expression gives us our complete solution. So this part is done. Now let us go to the singular solution now, because in the question they have asked us to find the singular solution. Now to find the singular solution, we have written two relations, that we will find the partial derivative of z with respect to a and we will put it equal to 0, and we will find the partial derivative of z with respect to b and we will put it equal to 0, and both equations we will try to simplify. We will try to write a and b in terms of x and y, and when we are done with that, we will put it back in our complete solution. We will put the values of a and b in terms of x and y back in the complete solution. That will give us the singular solution which we are searching for. Okay, so let us continue. Let us start with the first relation, that is dou z by dou a. So this expression which you have got as your complete solution, this you are now differentiating partially with respect to a. So what will I get? I will get x plus 0 plus 6a plus b plus 0. Simple partial differentiation. And this should be equal to 0. So this gives me that 6a plus b should be equal to minus x. Or you can say that b is equal to minus x minus 6a, right? Okay, let us keep it in a box. Now let's go to the second relation, which is dou z by dou b, right? Now, dou z by dou b. So we will get 0 plus y plus, now inside the bracket we will have 0 plus a plus 8b. This should be equal to 0. And you can say that a will be equal to minus y minus 8b. And this value of b we will substitute here. So this will give us a is equal to minus y minus 8b. So this becomes plus 8x and plus 48 a, right? This gives us a minus 48a, that will be minus 47a, will be equal to minus y plus 8x. And from here you are getting a as minus y plus 8x divided by minus 47. So this is what we were discussing here, that we will try to find expressions where we express a as a function of x and y, which you have done here, right? And same way we will try to write b as a function of x and y, which we will do in the next step. Now b, which you have obtained in this box. So now we will try to use this relation. So minus x, b is equal to minus x minus 6 times a. A already you have calculated here. So we will put it. So this is minus y plus 8x divided by minus 47. And from here you can write b as minus x minus, this will be 6y minus 48x divided by 47, right? So now let us take the LCM and try to simplify a little bit more. This implies that b will be equal to so this will be minus 47x and here it will be plus 48x. So that will be single x, right? And here it will be minus 6y divided by 47, right? Okay. So you have now obtained an expression for b also, where you have you have represented b in terms of x and y. That's all. Our job is done. Now what we will do in our complete solution, we will substitute these values of a and b. So what do I get now? This implies z will be equal to a, x. So what is a? Minus y plus 8x over minus 47 multiplied by x plus by, that is x minus 6y divided by 47 multiplied with y plus 3 times a square, that will be minus y plus 8x over minus 47 whole square plus ab, that will be minus y plus 8x divided by minus 47 multiplied by b, that is x minus 6y divided by 47 and plus 4b square. So plus 4 times b square. B is x minus 6y over 47. So b square means x minus 6y over 47 whole square. This expression which you are getting here contains no arbitrary constant. Both the constants a and b you have succeeded to remove, both of them. This solution which you are obtaining now is called as the singular solution. Okay. So this is your fourth type which we have discussed today, and hope this question was clear. And this is all about the first order nonlinear PDEs which we decided to discuss. And now in the next video I will start with second order PDEs. Okay, so take care all of you. We will meet in the next video.